Here in this question, find the heat used to convert 1 kg of ice at minus 10 degrees Celsius. The ice, the initial temperature of ice is minus 10 degrees Celsius. We are going to convert this ice to water at 100 degrees Celsius. Now we have to see that how many stages are involved here. First of all, you can see that I told you that the temperature of ice is minus 10 degrees Celsius. So at minus 10 degrees Celsius, I told you the ice will not melt. First of all, in the first stage, the temperature of ice will increase. The ice which was at minus 10 degrees Celsius, its temperature will increase, and that ice will gain the temperature 0 degrees Celsius. It will remain at ice. It was ice at minus 10 degrees Celsius, so it is now ice at 0 degrees Celsius. Now no state change is occurring, only the temperature is increasing. So in this case you have to apply the specific heat capacity of ice. You must be aware of that value of specific heat capacity of ice. This is the value for specific heat capacity of ice. Another thing, so for finding out the heat energy consumed in the first stage, you will have to apply this formula, the specific heat capacity. What is the formula for specific heat capacity? Yes, Q is equal to mc delta theta. Here, what is delta theta? Delta theta is the change in temperature. So, how much temperature change is occurring? No, minus 10 till 0. How to find out the change in temperature? This is the initial temperature. Minus 10 is the initial. Final is 0. So, delta theta is equal to 0 minus 10. Normally, students do not find out this difference. G, that it will not directly go to this. First of all, that ice has to gain the temperature. Initially, this ice was at minus 10 degrees Celsius. Now, what is the change in temperature of ice? The final temperature is 0 degrees Celsius. 0 minus 10 gives you answer 10 degrees Celsius. So, this is the change in temperature. So, this is delta theta. You will have to apply here. The mass of the ice is 1 kg. 1 kg into the specific heat capacity of ice is 2100, and the delta theta is 10. So, 21,000. What should be the unit here? Joules, because it is the heat energy, and I told you that the unit for energy is joule. Here you can see now this is ice. This is ice at 0 degrees Celsius. Now the ice is 0 degrees Celsius is going to change its state. Now it is converting to water. Water at 0 degrees Celsius. Here the state is changing. So which formula will be applied? Latent heat of fusion, LF. So what is the value of for specific latent heat of fusion of ice? 334 kilojoule. 334,000 joules per kg. This is the value for specific latent heat of fusion of ice. You can say that this is Q1 because this is the heat energy of the first stage. Okay. Now Q2, the heat energy consumed in the second stage, which is the specific latent heat of fusion of ice. Now here ice is going to be melting. Fusion, I told you that fusion means melting. So ice is going to melt to water. State is changing. No change in temperature is occurring. You can write kilojoule. I'm using all the quantities in joules, so that's why I have taken it into joule. In the last, when I'll find the final answer, then I'll change into kilojoule. Kg? This is the mass. I told you that the mass will be used in kilogram. Okay? Later, in the last stage, inshallah, I'll convert that joule to kilojoule. So, in this stage, the state is changing. Formula, what formula will be applied? Okay. Q2 is equal to? The formula is LF is equal to Q over M. Delta Q or Q. So Q2, here we are going to find out Q2 Here you can say that it is the stage for Q1, that is Q2. So Q2 is equal to M into LF. M into LF, mass into latent heat of fusion of ice, because ice is melting. So latent heat of fusion of ice is this. Apply the mass 1 into 334,000. So 1 multiplied by this is this much joule is the energy in the second case. Now the whole of the ice has melted to water. Now the third stage. In the third stage, the temperature of water is going to increase to 100 degrees Celsius. This is 100 degrees Celsius temperature. Now this is water and it is again water. This is boiling water. This is water at 100 degrees Celsius. Here the change in temperature is occurring. Here the change in temperature is occurring. So obviously you will have to apply the formula for the specific heat capacity of water. Here you were applying the specific heat capacity of ice, but here you are going to apply the specific heat capacity of water. So what is the specific heat capacity of water? Is equal to 4200 joules per kg degree Celsius or Kelvin. Okay. So here the heat at the third stage, so here I can say that this is Q3 is equal to MC delta theta. What is delta theta here in this case? What is delta theta here in this case? 100, yes, because the final temperature is coming 100. It is starting from 0 to 100. Now Q3, here I am finding out Q3. Q3 is equal to MC delta theta, mass 1, 4200. Yes, 42, this much, 42 tetra 0 joules. Now the total heat consumed, total heat, adding up these three, this is Q1, Q2 and Q3 will be added to find out the final answer. So the final answer is 775,000 joule. You can also write it into kilojoule. 775 into 10 kilojoule. You can also represent answer like this, 775 kilojoule, because kilo mean 1000.